Previously we graphed simple quadratic functions. Now we're going to graph more functions and look at the different characteristics. So the first thing about a quadratic is it has a vertex. So if you remember, a vertex could be a minimum value or a maximum value. It needs to be an ordered pair. So it needs to be an x, y. So the formula to find the vertex is negative b, so the opposite of b, divided by 2 times the a value. So this is in standard form, y equals ax squared plus bx plus c. So the b value is the coefficient of x, and the a value is the coefficient of x squared. So that gives you the x coordinate of the vertex, but remember you need to find the y coordinate. So to find the y coordinate, what you need to do is you need to plug in opposite b over 2a, which is the x value, into the function and solve for y. So I also wrote it using this notation, function notation. So the axis of symmetry is a line of symmetry. And it's going to go up and down, so you know it's going to be a vertical line, so you need to write an equation for the line, and it's going to be x equals opposite b over 2a. So if you know the vertex of the function, you can easily find the axis of symmetry because it's just the x value, and you have to write an equation for it since it's a line. So example 1, graph the function by finding the vertex, then label the axis of symmetry. So first I'm going to find the vertex, which is negative b over 2a. So I have a is negative 3 and b is 6. So I do opposite 6 over 2 times negative 3. So negative 6 divided by negative 6 is 1. That gives me my x value. Now I have to plug in 1 for x. So it's going to be negative 3 plus 6, which is 3 minus 1, so that's 2. So my vertex is at 1, 2. So what I do is in my table, I write in 1, 2. So because the parabola has symmetry, I'm going to make a table with symmetry. So I'm going to pick a number that's less than 1. So I pick 0 and then greater than 1, which is 2. And I want to go up by equal increments so I can use symmetry. So if I plug in 0, that's the same thing as getting my y-intercept. So my y-intercept is negative 1. So I'm going to write negative 1 right here. So because this difference is the same and it's symmetrical, this is also going to be a negative 1. Now I'm going to plug in negative 1 and 3. And if I plug one of those in for x, I can use symmetry to get the other side. So I'm going to plug in negative 1. So negative 1 squared is 1 times negative 3 minus 6 minus 1 is negative 10. So this distance is negative 10, or this difference is negative 10, and this distance is negative 10. So now I just need to plot these points to make my parabola. So negative 1, negative 10 is down here, kind of off the chart. 0, negative 1, 1, 2, 2, negative 1. Oops, I did 2, 1 instead of 1, 2. So I'm going to do 1, 2, 2, negative 1, and 3, negative 10. So it looks like this. So then label the axis of symmetry. So the axis of symmetry is the vertical line that goes through the vertex. So I'm going to write x equals 1 because that is the x value. Now second example right here, find the vertex. So remember, you're going to do opposite b over 2a. So this is going to be opposite of negative 6. So it's going to be positive 6 over 2 times 1 because the a value is 1. So that x coordinate is going to be 3 because 6 divided by 2 is 3. So now you need to plug in 3, f of 3, in for your function x and see what your output is. So 3 squared is 9, minus 18 is negative 9, plus 9 is 0. So the vertex is at 3, 0. I'm going to put that in the middle of my table, and I'm going to pick a number that's less than 3 and greater than 3. So if I plug in 2 into my function, f of 2 is 2 squared minus 6 times 2 plus 9. So 4 minus 12 is negative 8 plus 9 is 1. So this has to be 1 and this has to be 1. Now I extend my table further, so I'm going to put 1 and 5. So if I find f of 1, it's going to be the same thing as f of 5 because of symmetry. So f of 1 is 1 squared, which is 1 minus 6. Negative 5 plus 9 is 4. And you can check that on your own. I'm going kind of fast. So now I'm going to plot these points. 3, 0, 2, 1, 1, 4, 4, 1, 5, 4. Graph my parabola, and then label my axis of symmetry. It's the vertical line, and it goes through 3, so it's x equals 3. Now, one of the applications of parabolas is projectile motions, throwing something up in the air or having something go off from a cannon. So, you can model projectiles with a quadratic. So a projectile motion is defined as h of t. So h of t is the height of an object after t seconds. So looking at this function right here, it is a quadratic because you have the t squared. The v value, the coefficient of t stands for the initial velocity. Now, if you just drop something from a certain height, the initial velocity is just going to be 0. You're just dropping it. But if you take something and you fire it from a cannon with a certain velocity, that's going to be your v value. And c is the initial height. So example 3, suppose a particular star is projected from an aerial firework at a starting height of 520 feet with an upward velocity of 72 feet per second. How long will it take for the star to reach its maximum height? So we're asking for how long, so that means how many seconds, that's time, we're looking for time, will it take for it to reach its maximum height. So the functions of quadratics, so it looks like this. So maximum should be a keyword for finding the vertex. So first what you want to do is you need to write a function that models this projectile motion, which we're going to use this function model up here because we're talking about feet, meters. The coefficient right here would be negative 4.9, but we're going to use feet. So I'm going to write a function for this first, plugging in what we know. So I know that h of t equals negative 16t squared plus v times t, but I have the upward velocity of 72, plus the initial height, which is 520. So from this function, I'm going to figure out what the maximum is or what the vertex is. And I'm going to find the t value, which means I'm going to find the x value or the independent variable. So t is equal to opposite b over 2a. So opposite 72 over 2 times negative 16. So this turns out to be 2. But my units are seconds. 2 seconds. So at 2 seconds, so if this was 2 on the x-axis, it reaches its maximum height. So B asks, what will the maximum height be? So you want to figure out what is the value of h of t when t is 2. So plug in 2 for t. So when you plug in h of 2, you get negative 16 times 2 squared plus 72 times 2 plus 520, and I get 600 feet. So what will the maximum height be? I plugged in my time. Second example, example 4, you're trying to dunk a basketball and you need to jump 2.5 feet in the air in order to do this. The height that your feet are above the ground is given by this equation. What is the maximum height your feet will be above the ground? So what's the maximum height? So in order to find the maximum height, this is like making the shape of a parabola, we need to figure out the time that it reaches the maximum height. You're trying to find the vertex. So I do opposite B over 2A. Now B is 12. So opposite 12 over 2 times negative 16. And when I do that, I get 0.375. So at 0.375 seconds, you reach the maximum height. So to figure out the maximum height, you need to plug in 0.375 into this function. So when I plug in 0.375 in for t, I get 2.25 feet. So the maximum height is 2.25 feet. This is the time that it gets the height, but this is your actual height. So will you be able to dunk it? Well, you'll be able to dunk it if you jump 2.5 feet. So this is less than 2.5 feet, so no, because 2.25 is less than 2.5 feet.